Elon Musk is still the richest man in the world, and Tesla-bought Optimus is certain to push the Tesla chief executive officer's fortune to levels none of us could have imagined. Elon Musk has repeatedly stated that Tesla will produce billions of Optimus robots, and virtually everyone on the planet will want one, because at its core, this robot will help humans with a huge range of practical tasks. This vision goes far beyond creating a personal assistant robot. It aims to redefine the entire structure of global labor productivity. However, to turn that ambition into reality, Tesla has had to make some brutally pragmatic decisions. After production delays in 2025, the Tesla Bot 3 production line will finally begin operating at the Fremont factory in the Q3. This is not just a simple upgrade. It is a complete overhaul of the manufacturing infrastructure. To dedicate maximum resources to this project, Elon Musk will completely eliminate the Model S and Model X production lines in the upcoming second quarter, retiring the Model S and Model X in exchange for an army of robots. Does this sound like madness, or the mark of a visionary genius ahead of his time? Let us break down the almost unbelievable technologies inside Optimus 3 at the Fremont factory. At the end of last month, the global technology and financial communities were shaken by an announcement made during Tesla's Q4 2025 earnings call. Elon Musk officially declared an honorable retirement for the two iconic vehicle lines, Model S and Model X, in the Q2 of 2026. Yes, there will be no more Falcon Wing doors. This is not simply the discontinuation of outdated products, but a historic blood transfusion of infrastructure. The entire luxury car manufacturing operation at the Fremont factory will be permanently dismantled to make way for a massive construction site dedicated to building humanoid robots, Optimus 3. This decision confirms an irreversible truth. Tesla has officially transformed itself from an electric vehicle manufacturer into the world's largest physical AI and robotics empire. To understand why Musk is willing to bet the entire legacy of the Model S and Model X on Optimus, we have to look at the massive breakthroughs of the Gen 3 generation, which officially entered mass production in January 2026. Completely different from the clumsy demo prototypes of a few years ago, Optimus Gen 3 is a marvel of precision engineering. Its most astonishing highlight lies in its new hands, featuring 22 degrees of freedom, double that of the previous generation. Tesla has adopted a tendon-driven system, with the actuators relocated up into the forearm, freeing up space in the palm and fingers. This design allows Optimus to achieve near-human levels of dexterity. Combined with integrated tactile sensors, Gen 3 can perceive pressure with extreme finesse. It's strong enough to lift an engine block, yet gentle enough to hold a cookie without crushing it. This is the key that allows Optimus to leap far ahead of competitors like Figaro 2 or Unitree G1 robots that are still struggling with fine object manipulation in real-world environments. But it's not just about muscles. The brain of Optimus Gen 3 is inherited directly from Tesla's FSD-V15 autonomous driving system. Tesla approached the robotics problem not as scripted actions, but as a car with legs. The robot runs on an end-to-end neural network architecture, allowing it to learn by observing humans through video, powered by the latest AI-5 chip manufactured on an advanced cutting-edge process. Optimus can process billions of operations per second to localize itself in 3D space, recognize thousands of objects, and make movement decisions in the blink of an eye. This is the crazy technology Musk was referring to, a machine with no preset scripts, one that learns, adapts, and operates autonomously in the chaotic human world. Although Tesla has enormous battery resources from its electric vehicle business, the energy challenge for a humanoid robot is fundamentally different, forcing Musk to look to a solution from LG Energy Solution. Unlike mass-market vehicles that use LFP batteries, Optimus Gen 3 is equipped with NMC ternary batteries with extremely high energy density. This is critical because a humanoid robot must power dozens of motors at its joints simultaneously, along with a power-hungry AI-5 computing system, all within a very limited battery space. The battery pack provides roughly 3 kWh of capacity. In Optimus Generation 2, Tesla used a 2.3 kWh pack, so upgrading to a larger battery allows Optimus to operate continuously for at least 7 hours. Of course, this is still a projection based on Elon Musk's statements. The Tesla chief executive officer has even claimed that Optimus could eventually operate 24 hours a day, 7 days a week. The key advantage of LG's NCM batteries lies in their ability to store more energy per unit of weight, making them lighter and more compact. In robotics engineering, every additional gram creates a waste loop. A heavier battery forces joint motors to consume more power just to maintain balance and movement, which in turn drains the battery faster. By prioritizing energy density over the low cost of LFP batteries favored by many Chinese competitors, Tesla ensures that Optimus Gen 3 has the endurance needed to perform complex tasks such as elderly care or household assistance without constantly returning to a charging station. This choice highlights Musk's pragmatism. Instead of trying to manufacture everything in-house from day one, he opted for the most advanced battery technology currently available to ensure Optimus becomes a machine capable of real-world operation rather than just a laboratory prototype. Of course, for someone who constantly pushes beyond imaginable limits like Elon Musk, Optimus will never be confined to the basic functions of a walking machine. It needs to be more than that, and the most critical factor is comprehensive water resistance and waterproofing. In disclosures posted on X last month, Elon Musk implicitly confirmed that the Optimus Gen 3 generation will feature remarkable durability against environmental factors. This is not a nice-to-have upgrade, but a prerequisite for a robot to truly exist in everyday human life where water, humidity, and dust are everywhere. To achieve this, Tesla has carried out a major overhaul of the mechanical design. While Snort's earlier versions looked more like research projects with exposed wiring and actuators, the Optimus Gen 3 being built at the Fremont factory is taking on a completely different form. The robot is now enclosed in layers of high-grade polymers and tightly sealed engineering plastics, acting like a full-body raincoat that protects all sensitive electronic components inside. Most notably, the new hands with 22 of freedom are wrapped in a seamless elastomer membrane that not only improves grip, but also completely blocks liquid intrusion. This allows Optimus to perform tasks that were previously considered a no-go zone for humanoid robots, standing under a shower to clean itself, washing dishes in a sink full of water, watering plants, or even bathing pets. This water resistance is the true gamut. Imagine a real-world scenario if Optimus were not waterproof. A sudden rainstorm while carrying groceries from the car into the house, or a minor kitchen spill could turn a machine worth tens of thousands of dollars into scrap metal in seconds. By prioritizing this capability, Tesla is proving that it's not just building a high-tech toy, but creating an entity designed to survive and adapt. Elon Musk understands that reliability is the key to commercial success. No one wants to pay for a personal assistant they have to constantly protect whenever it rains. Integrating IP68 level water resistance or something equivalent also significantly reduces maintenance costs, preventing oxidation of mechanical joints and electrical short circuits in hot, humid environments. With EVs, Tesla can take advantage of components that already exist in the market. But with Optimus, almost everything has to be built from scratch, using first principles thinking from actuators, motors, and gearboxes to power electronics. Every part is customed, designed to match the biomechanics of the human body. That's why Elon Musk has admitted this process will follow a long curve, slow and painful at the beginning, but accelerating rapidly once the supply chain bottlenecks are resolved. And here's the key point. Even though final assembly happens in the US, the heart and soul of Optimus Gen 3's manufacturing process lies in China's supply chain ecosystem. Elon Musk has confirmed that roughly 50% to 63% of the Gen 3 Tesla bots components will be sourced from Chinese suppliers. This isn't a random choice. Yeah, it's an economic necessity. According to estimates from Morgan Stanley, if Tesla were to completely remove Chinese components from the Optimus supply chain, the production cost per robot would skyrocket from around $46,000 to as much as $131,000. Meanwhile, Tesla's goal is to bring the retail price down to about $20,000, roughly the cost of an affordable car. Leveraging China's highly mature industrial robotic supply network allows Tesla to cut costs by as much as 5 times, compared to manufacturing entirely in the US. Strategic partners are now coming into focus, forming an Optimist supply chain similar to what Apple built for the iPhone. Zhejiang Sanhua, has been selected to handle thermal management systems. Ningbo is responsible for complex actuators, and Everwind supplies ultra-sensitive sensors. China currently dominates large-scale, low-cost component manufacturing, something no other country can replicate overnight. Elon Musk has openly acknowledged that China is the biggest and essentially the only serious competitor in the humanoid robotic space. Companies like Unitree have already launched humanoid robots priced between $6,000 and